Hey everyone! Today we'll be learning about the quadratic formula. You'll need the note sheet that I gave you guys in class, a pencil, and probably an eraser too. So first of all, you guys probably have some questions about what the quadratic formula actually is, and why we have to use it, and when we have to use it. So the quadratic formula is basically just a formula used to find the x values or the roots of any quadratic problem or equation. And normally, you would use factoring or computing the square to find the values of x, but sometimes when the numbers don't factor, or everything's just too messy, or you just don't know how to factor, or hopefully you do know how to factor, but sometimes using the quadratic formula is easier, especially when the numbers are larger or fractions or decimals are involved. So, I know it looks really complicated with the picture on the right, but we'll get to what all the different numbers and letters mean on the next slide. So this is the standard quadratic equation of any quadratic formula that you're going to have to solve. So notice that the a, b, and c are the same as in the quadratic formula, which we saw on the last slide. The most important thing to remember here is that it has to equal 0, or else the numbers won't be valid when you plug them into the formula. So a, b, and c are just normal integers, and a and b are just the coefficients of the x values. So let's take another look at the quadratic formula so we can make everything less confusing, because I know there's a lot of different parts in there, but it's actually not that complicated. One of the most important things to remember is the plus minus after the negative b. If you don't include this, you will only have one x value, and you're always supposed to have two x values, or roots, when you're solving a quadratic problem. So the next thing to remember is that everything is divided by 2a, not just the square root of b squared minus 4ac, not just the negative b, it's everything, especially the plus and minus. Because I know that's easy to forget, but it's just everything's divided by 2a. So now we're going to work through some example questions together so we can clear up any of the questions you guys might have about how to actually use it when solving a problem. So here's example number 1, and as you can see, I've written the standard quadratic equation underneath the actual problem. So in this specific example, a is equal to 1, b is equal to 3, and z is equal to negative 4. And a is often equal to 1, because most of the time it's just x squared. So using our specific values of a, b, and c, I've actually plugged them into the formula for you guys so that you can see how they compare to the actual quadratic formula. And feel free to pause the video at this point so that you can make sure that you understand everything correctly. So here I've worked through the first half of the problem for you guys. So first, 3 squared is equal to 9, and negative 4 times 1 is negative 4, times negative 4 is 16, positive 16. So then we can simplify it to negative 3 plus or minus square root of 9 plus 16 divided by 2, because 2 times 1 is equal to positive 2. From there, negative 3 plus or minus the square root of 25, because 9 plus 16 is equal to positive 25 divided by 2. So here I've worked through the second half of the problem, where we split the formula into two different roots, so that we can get the two different x values. So the first one is negative 3 plus 5. Oh, divided by 2. So 5 minus 3 is equal to 2. So 2 over 2 is equal to 1. So one of the roots is x equals 1. And the second root is negative 3 minus 5 divided by 2. So negative 5 plus negative 3 is negative 8 divided by 2. So this is equal to negative 4 divided by 1, which is also equal to negative 4. So the answers to example 1 are positive 1 and negative 4. These are the x values, also known as the roots. So normally, there's only one negative root and one positive root, so that you can decide which one to use when solving a word problem. Because the negative root won't work for things like distance or height, so you always use the positive one when solving a word problem. So here's example 2. 2x squared minus 4x minus 3 equals 0. Here I've written the standard quadratic equation underneath it again, and also included the standard quadratic formula, so that you can see how the normal formulas compare to our example. So in this example, a is equal to 2, b is negative 4, and c is negative 3. Don't confuse the negative signs with the positive signs, because it's always plus bx and plus c. So if it's a negative, the values of b and c are always negative. And then I've also plugged them into the quadratic formula underneath that, so that you can see how they compare. So, first of all, negative 4 squared is equal to 16, because negatives don't count when you're doing the powers. And then negative 4 times 2 is negative 8 times negative 3 is positive 24. Remember, when you're multiplying negatives, they're always positive. And then 16 plus 24 is equal to 40. So the simplified version would be 4 plus or minus the square root of 40 divided by 4. But 40 is not something that can be square rooted evenly, so this is where it gets difficult. So because 40 cannot be square rooted evenly, we need to find the greatest common factors of 40. So here, 1 times 40 is 40, 2 times 20 is 40, but also 4 times 10 is 40, and 4 can be square rooted to become 2. So we're going to use those two numbers. So then it's going to be simplified to 4 plus or minus the square root of 4 times the square root of 10 divided by 4. All of it's divided by 4 still. Then we find which number goes into all of the three numbers other than the square root. So 4, 2, and 4. So here, the number 2 goes into 4, 2, and 4. So, because 2 times 2 plus the square root of 10 is 4 plus 2 times negative 10, and 2 times 2 is equal to 4. So then the simplified version of all of that would be 2 plus or minus square root of 10 divided by 2. So for example 2, the two roots are x equals 2 minus square root of 10 divided by 2, and x equals 2 plus square root of 10 divided by 2. So when you have the square roots of numbers that cannot be square rooted evenly, you just leave them in the square root form so that they can be completely exact. You only convert them to decimal form when you're asked to approximate or estimate. So keep this in mind when you're answering any type of quadratic problem. So this is the end of my lesson on the quadratic formula, and I hope it was really helpful for you guys. The notes that I gave you guys in class, just follow along with all the examples that we did, so you can go back and look at them as many times as you want. And they also show the different equations that we went over, and the quadratic formula as well, and all the different things that you have to remember. Here are all the works that I referenced when making this video. I hope you guys learned a lot about the quadratic formula. Bye!